This video is supposed to be step by step showing you how to problem solve the final exam from last semester. However, the reason why I'm doing this is just to make sure that everyone understands what's going on last semester. And then your test is going to have to take notes on this, and then when you go home I want you to take the question that I have and change the number and derive the equation yourself, because when you come into the next period I expect you with 100% passing, because I show you step by step of how to do it already. And make sure you have notes written down before you come to class, unless otherwise your points will be deducted and that grade will not be changed. Let's get back to question number 1. So question number 1 is the concept of momentum, and it is elastic. m1v1 plus m2v2 is equal to m1v1 final plus m2v2 final. So it says is initially that the system is initially at rest on a frictionless surface, so it doesn't matter what it is. So the total of momentum on the left hand side should be 0. Pi is equal to changing of Pf and Pf. But then they said that the mass m1 is equal to 3m, so I'm just going to go ahead and label 3m. Final velocity of m1. So look at the question. It says after the thread is cut, the spring is released. The object with a mass of 3m has a speed of v plus this is 4m, and we're looking for this one. So basically we're trying to rearrange the equation to solve for the Vf. So what I would do is I would do this. I'll change that to 3mv is equal to 4m Vf, and now I isolate this one by itself. So Vf is equal to 3/4 V. The reason why I'm not getting the negative, because this is speed, and the speed is actually absolute velocity, which is only positive. If they were to be asking for velocity, then it has to be negative, because velocity is a vector, it has directions to tell you whether it goes to the left or it goes to the right. So basically what this is telling you is that, after final velocity, the mass of 4m is actually traveling to the left. So question number 2, we are talking about, so this is called what we call elastic, and however this is, when you read the second question, it say it stick together. So basically what it will tell you that this is the types of collision which is inelastic. So you write that the same thing. Pi is equal to Pf because the momentum is conserved. m2v2 plus m1 plus m2 v2f. I'm just gonna say vf, that's what we're looking for. So look at the questions. What will tell you that m1 is actually 10, velocity is 4, plus m2 is 5, velocity 2, so it's 10 plus 5, which is 15 vf. So you're solving for vf. So basically when you add them up, so it would be 50 Vf. So you do this way right here. Vf is equal to 50 divided by 15, and basically that is equal to 3/1/3. That's a fraction that you need to actually understand. So from now on, instead of using calculator, we're not gonna be using calculator anymore, because we want you to be able to figure out how to simplify the math based on these equations. So now I want you to go ahead and look at question number 3 to see whether or not it will be elastic or inelastic while I'm erasing the board. Okay, now look at question number 3. Number 3 is a little bit different and it's a little bit tricky. So mass M is traveling to the right, that's positive. And mass small m is traveling to the left with 2m, that's basically is that. Okay? They're traveling on a frictionless, so there's no work being done. And it says stick together. So basically it says stick together. Stick. Which is basically it is inelastic. So basically they're telling you that question 2 and question 3 are somewhat related. Okay, go ahead and do the math. Plus m2 v2, right, is equal to m1 plus m2 vf. That's what we're looking for again. pfy. So m1 is m, so big M. That's v. However, when it says m2 is smaller m, but velocity in the 2 is negative, is that? It's direction to the left. That's why I have to have negative sign on there. So m plus smaller m, vf. So I'm just going to combine the term. So I have velocity, so I'm just going to take velocity outside. So that will be m minus 2m, because you know you do algebraic. So that's minus 2mv, correct? And that's mv, yeah, that's the same. M plus m, vf. So looking for vf, we're just gonna have to divide that one by itself on both sides of the equation. So your final velocity should be m minus 2m v m plus m. So this is the final formula to calculate this is the final equation, which is representing the final velocity when those two blocks sticks together and move at a new speed, which is that. So now I want you to go ahead and look at question 4 to figure out whether or not what concept should you be looking for, should you be applying in order for you to solve this problem. So now you know question 4. I'm just gonna make it easy on you by drawing the graph. So I'm doing question number 4, question number 5, and question number 6. 4, 5, and 6. Since they're the same one, okay? So question number 4 is very easy because we know that the graph itself is f and this is time. So it's a calculate the impulse applied to the mass during the first 25 seconds. So basically the area under the curve is basically F times t, and that is equal to momentum, and this is called impulse. Impulse is equal to change of momentum, same thing. And since they were looking for impulse, so it is F times t. So basically that's what it is, but there's more into it because the first 10 seconds, the area is force times 10, that's base times height, plus 1/2 base 15 times 4, which is equal to impulse. It's the same thing. So the answer is 70. So that being said, that the total is 70, okay, Newton seconds. But however, when you're looking for question number 5, it's the same thing. I'm just gonna say impulse is equal to mass time this, because it's a change of momentum. To make this correct, so our impulse is 70, is equal to mass, which is 7 Vf, that's what we're looking for, minus Vi. Velocity initially was only 3 meters per second, so you have to do the math right here. So that would be 7 Vf minus 21, 70. So 70 minus 21 is equal to 7 Vf. 49, 7 Vf. You know, divided by 7, divided by 7. So your final velocity is actually 7 meters per second. However, for question number 6, is F equal ma, because you're looking for acceleration, which is equal to the force divided by mass. So when we're looking at the graph right here, for the first 10 seconds, the force is constant, which is equal to 4. So acceleration is equal to 4 Newton divided by the mass, and the mass is 7. So acceleration equal to 7 meters per second square. And that's how you figure out the acceleration